Hello everyone, I'm Rémi Portelas, a third-year PhD student supervised by Pierre-Yves Oudeye from INRIA Bordeaux and Cathy Hoffman from Microsoft Research Cambridge. In this video, I'll briefly present part of the work we've done during my PhD, which is about designing and studying teacher algorithms for deep reinforcement learning students. I'll first go over some background, and then I'll present ALP-GMM, a new teacher algorithm we designed, followed by Teach My Agent, a benchmark for teacher algorithms, and I'll also briefly mention other projects. So now for the background, we are working on training deep reinforcement learning agents. And so basically you have an agent that can send actions to an environment, and it learns to maximize reward by receiving states, or observations and rewards. And so an example is an agent learning to solve this locomotion task of going forward in a 2D environment with stumps while being embodied in a bipedal walker. So this is a classical deep reinforcement learning task. We are considering the more interesting problem of learning to solve multiple tasks. So learning a policy that can generalize its behavior over multiple tasks, for example, coming from a task space and creating tasks from using procedural content generation. And so here the question is how to select the best training curriculum, how to give the right task at the right moment for the learning agent. And so that's what teacher algorithms or automatic curriculum learning algorithms are about. And ALP-GMM is a new teacher algorithm that we presented in this article, accepted at Choral 2019. And here the problem setup is similar to what I've discussed in the background. We have multiple tasks coming from a task space. And so how to do expert knowledge-free automatic curriculum learning. So how to do automatic curriculum learning in a complex continuous task space without initial knowledge over what the learner is able to do, where to go, where to start in terms of which tasks to begin learning with. And so we consider a task space that could contain unfeasible subspaces, irrelevant dimensions, a nonlinear difficulty. And so how do you teach students without knowing their initial abilities on this space? And so to answer that, we consider this problem as a black box teaching optimization, in which the algorithm, the teacher algorithm, only observes rewards obtained by the students when sending a new task. So it's only the interaction is only about sending a task and observing the reward the learning student is getting on it. And that's all. The teacher is not allowed to look at the details of the learning mechanisms of its student. And so given that, we propose ALP-GMM, which stands for Absolute Learning Progress Gaussian Mixture Model. And I won't go in details about it, but the main idea is that this algorithm is about detecting subspaces in the task space in which the deep reinforcement learning student is making progress. So it's focusing task sampling in subspaces where the learner is making progress. And so we showed that this ALP-GMM outperforms random curriculum, other previous learning progress-based teachers, and sometimes even handmade expert curriculum. And it does outperform them in this parcours, 2D parcours with stumps we presented earlier, given different students. And it also outperforms them on more complex 12-dimensional task space with more complex and abstract obstacles. So ALP-GMM is a teacher algorithm that do not use expert knowledge and allows to provide good generalization for deep reinforcement learning agents. And it is open source, so I invite you to have a look at it if you're interested. And then following work we've done that we will be presenting at ICML 2021 is Teach My Agent, so a benchmark for automatic curriculum learning. And this comes from a simple observation. The automatic curriculum field right now is quite a mess. Everyone, there is a lot of work, which is amazing, but everyone is doing its own thing, and so it's hard to compare works. So it's hard to compare one teacher from one another, because in each article they are not using the same environments. They are not comparing to all other ACL algorithms, and they are not even using the same amounts of expert knowledge. So it's hard to shop for an automatic curriculum learning method. And that's why we designed Teach My Agent, as there was no benchmark for automatic curriculum learning methods. So Teach My Agent contains recent state-of-the-art ACL algorithms that we implemented in a common API based on open source code, or just by re-implementing the algorithms from scratch. We also have two state-of-the-art deep reinforcement learning students and two environments that use procedural content generation to have a rich task space. So we have these stump tracks that we, so the one used in the LPGMM paper, but we also have a new parkour environment with a 6-dimensional task space, and that contains an uneven terrain generated using a neural network, and also with water, with creepers in the ceiling. And this allows to have to consider a lot of embodiments. And so we add to this to Teach My Agent benchmark multiple walkers, multiple types of walkers, but also climber morphologies and swimmer morphologies. And it's interesting to have all of these, because we can test whether a teacher algorithm is able to be high performing at teaching for each of these morphologies. We consider two types of experiments, so global performance assessment in this parkour environment, and also skill-specific performance assessment, where we use this the stump track environment, and we create variants of it to test whether teacher algorithms are good at training multiple types of students, or at training students on unfeasible on task spaces with a lot of unfeasible tasks, or training students that can forget, these kind of things. So that's Teach My Agent, and we use it obviously to conduct a large-scale experiment, so both on skill-specific experiments and on global performance experiments. I won't go in details about that, but we do show that expert knowledge-free methods like ALP-GMM are quite competitive with respect to other state-of-the-art approaches that can use more expert knowledge. So yes, that was Teach My Agent, a platform to study and compare ACL methods. It's only the version 1.0. We expect to add more teachers and more environments, hopefully with the help of a community of interested ACL researchers. So here are a few links for the website, code, and paper. So very briefly, I'll mention other contributions we've made. So we've worked on a short survey of automatic curriculum learning for deep reinforcement learning. We identified 3 dimensions of automatic curriculum learning and surveyed related recent work on using this. We've also worked on meta-automatic curriculum learning, so that is designing teachers that can leverage previous teaching experience to better train a new student. So they learn to teach. And finally, we are working on socially proficient agents. So how to enable deep reinforcement learning agents to interact with natural language and movement with other peers. That's about all of it. Thank you.